In the second part of 5.3, we're looking at different types of multiplication problems that something interesting will happen, like the difference of squares and a binomial squared. So yesterday we looked at foiling, we looked at multiplying polynomials, and when we did this, when we FOILed a binomial times a binomial, we followed these acronyms. And in the special products problems that we see today, interesting things are going to happen. So the difference of squares in algebraic terms, meaning in variables, it looks like this, like a plus b times a minus b. So the difference of squares, a plus b times a minus b, I should kind of actually write this higher so I have room to write underneath of it. Difference means subtract, and when you multiply something that looks like this, it's the same number here. If you see these A's, they're the same, and these B's are here, but one's positive, one's negative. When you have something like this, something very interesting happens. If I was to go to FOIL this, I would multiply the first term, so a times a, that would be a squared. And then the outer terms would be a times negative b, that's negative ab. Then the inner term, b times a, is a positive ba. And then the last term, positive b times negative b, would be negative b squared. So when we go to do this, and we multiply everything out through FOILing, usually the middle two terms will be able to be simplified. So if we look here, negative ab plus ba, I know that b and the a are in opposite spots, but because of the commutative property, you could switch that around to say ab. So this negative ab and this positive ab actually cancel out. So this whole thing ends up just equaling a squared minus b squared. When you have the difference of squares, what happens is the final answer will be the first number squared minus the second number squared, because the middle two terms will always cancel out. That's why they're considered special products, because this special thing will happen. If we have real numbers like x plus 3 times x minus 3, there's two ways you can solve this problem. You can solve it normally. You can solve this problem normally by FOILing. X times x is x squared. X times negative 3 is negative 3x. 3 times x is a positive 3x. And 3 times negative 3 is negative 9. So you can FOIL this as normal. And then you'll see that the middle terms will cancel out, since negative 3x and positive 3x will add to 0. And then you can see you're left with x squared minus 9 as your final answer. Or you can look at the problem in the very beginning and realize this is a difference of squares because you have an x here and an x here. And then you have a positive 3 and a negative 3. If you realize this is a difference of square problems, you don't have to do all of the work. Your final answer will be x squared minus 9. So it's the first multiplied, the last multiplied. That's your answer in the end, because the middle terms will cancel out. This only works for difference of squares. If this was not the same number here, if this was like x plus 3 times x minus 2, it won't happen. If this was an x and this was a y, it won't happen. It's only if you have an x here, or the same variable. It doesn't have to be x. But the same variable here, the same number here, but opposite numbers, then it will work this way. And then a binomial squared means if I give you a problem like this and I said, take a plus b and square it, a lot of students think that what you would do here for this problem is just distribute the squared to everything on the inside, and then that would be your answer. Please realize that when we were in exponents in section 5.1, there was a rule that said if you had an exponent on the outside of a product, you could distribute that exponent to everything on the inside. It was called the product to power rule. This rule only works because it's called product to power. And the product to power rule says you can distribute this to everything on the inside to be a squared times b squared. This right here is not a product. This is a sum. There is no sum to power rule. You cannot distribute the squared to the a and the squared to the b and then have your final answer be a squared plus b squared. It's one of the biggest mistakes that I see students do all of the time, and it does not work. The product to power rule only works if the numbers on the inside are being multiplied. Because the numbers on the inside are being added, it will not happen. It could be added or subtracted, but either way, it's not going to be able to be simplified easily using this rule. This rule only works for products. So when you go to simplify a binomial squared, a plus b squared is the same thing as a plus b times a plus b. So the first thing you would have to do is expand this and write it out as a plus b times a plus b. The problems will always be given in this form, but they then want you to make sure you understand you have to expand it and then FOIL. FOILing means then multiply a times a and get a squared, a times b, which is ab, b times a, which you can write it as ba or you can write it as another ab. You can switch the order because of the commutative property. And then b times b is b squared. So this final answer ends up being a squared plus 2ab, because there's two of them on the inside, plus b squared. That is totally different than just a squared plus b squared. So if you think that this little squared can just be distributed to everything on the inside and have your final answer, that is wrong. You have to expand it out and then multiply it using FOILing. What's going on here? Oh. I don't know why that won't go away, but with number form, so instead of using variables with numbers, we would just, I can make up anything like x plus 2 squared. X plus 2 squared will not equal x squared plus 4. It does not work that way. In order to simplify x plus 2 squared, you first will expand it as being x plus 2 times x plus 2. Anytime you have an exponent, the exponent says that's how many times the base is being multiplied by itself. I wrote x plus 2 twice because x plus 2 is the base of that exponent. So I would multiply x plus 2 times x plus 2. And when I do that, x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. So I get this long polynomial, x squared plus 2x plus 2x plus 4, which I then can simplify to be x squared plus 4x plus 4. So in both of these situations, you're going to be seeing a difference of squares, which will end up, the middle terms cancel out. And then the binomial squared, the problems will be set up differently because you'll have just one binomial here and raised to the second power. And then you have to expand it and then multiply and simplify. So in these examples here, we're then actually going to try some special products to see what happens. In letter A, if you can look at this and realize, okay, this is a difference of squares problem, you could easily get the answer without having to do the FOILing for everything because the insides are going to cancel out. So the outer number and the inner numbers will cancel out in the FOILing. So really all you have to multiply is the first and last. If you don't really know if you can identify that it is a difference of squares by looking at the problem, then all you need to do is multiply everything out like you normally would. And then as you simplify, you'll be able to realize the middle terms cancel out, and then you'll have your final answer in this case will just be x squared minus 25. But like I said, if you understand that this is a difference of squares from looking at the problem, realizing that this says x minus 5 times x plus 5, which is the opposite, that all you need to do is multiply the first and last, that's x squared minus 25, the final answer. But you can FOIL every single time and get your answer as well. So letter A is going to be a difference of squares, but letter B is a binomial squared because this says take u minus 7 and multiply it by itself. So the first thing you have to do in this one is expand u minus 7 times u minus 7. And then when you do that, you're going to be just FOILing. So you're going to multiply the first, which is u times u, that's u squared. The outer, which is u times negative 7, that's negative 7u. The inner, which is negative 7 times u again, another negative 7u. And then the last, negative 7 times negative 7 is a positive 49. So this one, the middle terms do not cancel out because this is the same exact thing multiplied by itself, which is different than the difference of squares. But we can simplify the middle. The middle will end up simplifying to be negative 14u. So the final answer for this one would be u squared minus 14u plus 49. What ends up happening when you multiply a binomial times itself is that you multiply the first terms, that's where we got the u squared, and the last terms, that's where we got the 49 at the end. And then the middle term will actually be 2 times one of those numbers because you're going to get the same thing twice. So if you understand that kind of mental math, you can not really even have to expand it. Some people might be able to look at this and just get the answer just from seeing that it's going to be u squared and then 2 times the negative 7s, the negative 14 in the middle, and then the plus 49. All right, for letter C, it's going to get a little bit more difficult because now instead of just having like a plain A, it's 2A, so it's going to make everything a little bit larger. And the same thing for this, we now have 2 variables, but it still worked the same way. If you understand that this is 2A plus 5B times the opposite, 2A minus 5B, then you can realize that you're going to just follow the difference of squares. The final answer will just be the first times the last, and that will be it. If not, go through the whole FOILing process. 2A times 2A is 4A squared. 2A times negative 5B is negative 10AB. 5B times 2A is a positive 10. BA or AB in any order, it's going to still cancel out. And then 5B times negative 5B is negative 25B squared. With a difference of squares, these middle 2 terms will cancel out because they're opposites. So you're left with only the first terms, 4A squared minus 25B squared. All right, we'll do one more together, and then you're going to try a couple on your own. So 3x plus 8 squared. You cannot use this rule here. The product to power rule does not work for this because this is not a product to a power. This is a sum to a power. The only way to simplify this is by expanding it and multiplying it out. So to expand it, that means take 3x plus 8 and multiply it by 3x plus 8 since this is a power of 2. If that power of 2 is actually a power of 3, let's say, which I want to try before we leave today, then you would be multiplying that number times itself 3 times. So because this is only multiplying by itself 2 times, you will then just follow the FOILing process. 3x times 3x is 9x squared. 3x times 8 is 24x. 8 times 3x is another 24x. And 8 times 8 is 64. So then the final thing you would do is add the 24x plus 24x, and that would be 48x. So this would be 9x squared plus 48x plus 64, and that would be your final answer for that. Okay, what I want you to do is go ahead and try those next 4 problems on your own. Then we'll complete example 5 together. So go ahead and try the You Try problems below. I'll give you a few minutes. right, so it looks like most students are finished. So let's go over these answers quickly. So the first one, x plus 2 times x minus 2. That's a difference of squares, so if you understand that, you can just go ahead and multiply the first and last, and that will be your answer. Or you can FOIL the whole thing out, and then when you do simplify it, you'll realize the answer is x squared minus 4 as your final answer there. For number 2, this is a binomial square, so you have to take this and expand it. X plus 5 squared is x plus 5 times another x plus 5. This one, the middle terms will not cancel out because they're not opposite, so the middle terms will actually double because it's the same thing twice. So when you multiply x squared, you're going to have two 5x's, so that those can simplify to be 10x, and then the last term would be plus 25. So that's x squared plus 10x plus 25. And then in number 3, as soon as I see this, I'm looking at they look very similar but opposite. So when you go to solve this, you can either FOIL the whole thing, or if you understand it's a difference of squares, you only have to multiply the first, which is 6x times 6x. That's 36x squared. And then you multiply the last. So that's negative 9y times positive 9y. That's going to be negative 81y squared. If you FOIL the whole thing out, that's fine. The positive 54xy will cancel out with the negative 54xy, which the whole middle terms will go away then. And then the last one, even when I see this, I have to write it out and do it. I can't just figure out what this is in my head. Some of you might be able to, but not me. 2x minus 7y squared is the same thing as 2x minus 7y times 2x minus 7y. I have to always FOIL these types of problems out. I cannot use any of the power rules from 5.1 because this is subtraction or addition, it's not multiplication. So now when I do FOIL it or I do expand it and I go to FOIL, I FOIL using multiplication to multiply every term in one by everything in the other. So since this one's a little bit more complicated, I'm going to do the whole thing out. 2x times 2x is 4x squared. 2x times negative 7y is negative 14xy. And I prefer to put the x in front of the y, but if you had yx, it's the same thing. Negative 7y times 2x, I'm going to write negative 14, and I'm going to write xy in the same order just because that makes more sense in my brain. And then negative 7y times negative 7y is a positive 49y squared. So then when I go to simplify this all together, this term and this term can be combined together since they're like terms. 4x squared minus 28xy plus 49y squared would be the final answer for that. Okay. And then in example 5, the last set of notes that we need to go over is when you take a binomial and you cube it. This is about the longest type of problem we'll see. Well, we won't see an exponent larger than 3 and have to do this by hand. So when I take y minus 2 and I'm raising it to the third power, that means I'm multiplying y minus 2 times y minus 2 times y minus 2. You are not able to just give the y and the 2 a power of 3 and say that that's the final answer. When you have a sum or a difference inside of the parentheses, and you have an exponent on the outside, you have to expand that sum or difference however many times the exponent says. So if I said simplify y minus 2 to the power of 3, your first step would be to expand it and write y minus 2 times y minus 2 times y minus 2, the amount of times that the exponent says, which is 3. In order to simplify this, you have to multiply it with FOILing, but you have to do it one step at a time. There is no mathematical formula to do it all at once. So what you would have to do first is multiply these two together, and then get that answer and multiply that answer by the third y minus 2. So to multiply these two together, I'm just following the formula for FOIL. That's going to be y squared minus 2y minus another 2y plus 4. I'm going to simplify that. Y squared minus 4y plus 4 is what the first thing equals. And now don't forget that this whole time I did not use this thing right here yet. I need to now multiply this 3-termed polynomial, which is called a trinomial, by this 2-termed polynomial, which is called a binomial. Now I need to multiply y squared minus 4y plus 4 by y minus 2. So when you do this, You have to basically multiply every single term in one of the sets of parentheses by every term in the other. So I need to multiply y squared by y and y squared by -2 first. So y squared times y is y to the third power. Y squared times -2 is -2y squared. And then you move down the line. Now you need to multiply -4y times y and -4y times -2. -4y times y is -4y squared. And -4y times -2 is a positive 8y. Moving down the line, I now need to multiply 4 by y and 4 by -2. 4 times y is 4y, and 4 times -2 is -8. Once I have that all done, I have 1, 2, 3, 4, 5, 6 terms that can be simplified by finding like terms. They're kind of all in order, and in order to put your answer in its final correct formula, you're going to want to go from the largest exponent down, because that's what standard form is. So y to the third power has nothing to combine with it, but I can combine -2y squared and -4y squared to be -6y squared. I can also combine 8y with 4y to be a positive 12y, and then the constant number -8 has nothing to combine with it. That will be your final answer in the end. So if you're given ever something raised to the third power, you have to do it in 2 steps. You multiply 2 of them together, get an answer, and then multiply that answer by the third one you didn't use yet. Then you'll come up with this final answer. Notice that that is a whole lot different than if you just gave this y a power of 3 and this 2 a power of 3. That would say y to the third power minus 8. That's not what the answer is. So that rule does not apply for something like this. It only applies for when you have a product inside. So if you haven't already, go ahead and try the U-try problem, the x plus 5 to the third power. I'm going to erase all of my stuff here that I just wrote so that I have room to do this as well. So go ahead and complete x plus 5 to the third power. Sure. Alright, so when we go to simplify this, first thing you would do is expand it by writing x plus 5 3 times. Then the next thing you would do is take 2 of the x plus 5s and multiply them to get x squared plus 10x plus 25. That's what the sum of 2 of these are. Then we take that and multiply by the third one. Now, even I need to show my work for this because it starts to get a little bit confusing. So I multiply x squared times x and get x to the third power, x squared times 5 and get 5x squared. Then going to the line, 10x times x is 10x squared, and 10x times 5 is 50x. Then 25 times x is 25x, and 25 times 5 is 125. Then you would just go through and combine any like terms. X to the third power does not have any like terms, but 5x squared and 10x squared can be combined together to be 15x squared. 50x and 25x can be combined to be 75x, and then plus 125 at the end. So that would be the final answer for that type of problem. All right, the last thing we're going to do today for notes is on the last page here. There is a web assigned problem that's going to be like example 6. So I'm going to make sure we go over it together. So sometimes we can use application problems like in geometry to write polynomial functions. So right here we have a rectangular box. I can see its length, width, and height. So the length and width are n plus 2 and n, and the height is n plus 4. The polynomial function says, or it's asking us to write a polynomial function that represents the volume of a box. To find the volume of a box, you need to multiply the length times the width times the height. So in order to multiply these things out, we would be multiplying n times n plus 2 times n plus 4. Anything that has more than one term, you're going to want to use parentheses around it. So it's going to be n times n plus 2 times n plus 4 like this. Now this is not a polynomial function. We're going to want to multiply this all out to make it one. So to simplify this for the answer to letter A, I would multiply n times n plus 2 first, which is very quick and easy because it's just one term times the other ones. That'll turn that into n squared plus 2n. Now I need to multiply that entire thing by n plus 4. As soon as you have more than one term, you then need to put parentheses around it and then follow the FOIL process. Now when I go to simplify this by multiplying it out and putting it into a polynomial, I'll do n squared times n. That's n to the third power. N squared times 4, that's 4n squared. 2n times n, that's 2n squared. And 2n times 4, that's 8n. Combining the like terms in the center, the final answer would be n to the third power plus 6n squared plus 8n. That would be the polynomial function that represents the volume of that box. Then they're asking us for what the volume would be if the shortest side is 3 inches. So you have two options. You can either use the actual box and replace these numbers in. You can put 3 in. This is the shortest side, which is 3. If this side is 3, then this side would be what? If n is 3, then what would this side be? 5, yep, because 3 plus 2 is 5. And then what would this side be? 7, exactly. So in order to find this quicker, you can just do 7 times 5 times 3 and get the volume. So 7 times 5 times 3 is 105. So for B, just multiply these together, and it would be 105. Because they tell us that it's inches, and whenever you find volume, you use the power of 3. I'm just going to be particular in that it's 105 inches cubed. Or you could have used this function here. You could put 3 in for n here, here, and here. And the function will still give you the 105. Then the last thing in letter C, it's asking us to find the polynomial function that represents the area of the base of the box. So the base of the box is the bottom. You'd have to understand what 2 little parts you would need. You would need the n plus 2 in the end. In order to get the base of the bottom, which is going to be a box, n plus 2 times n, you would just multiply n times n plus 2. Multiply that out by distributing the n. This would be n squared plus 2n is that final answer for the area of the box.